So the next section discusses wave behavior. So basically what waves do depending on what you're interacting with. So wave interaction, so when a wave meets another object, or if you're going to see some kind of interaction occurring. So another example would be when a wave travels or passes into another medium. So in other words, going from a solid to a liquid or a gas to a solid. Example of this with reflection, diffraction, refraction, interference, resonance, all these things we'll talk about. And a lot of these you've already experienced before or you've seen yourself. So reflection is when you have a wave that strikes an object and bounces off of it. So let's say, for instance, you have a light ray, hits a mirror, bounces off. The color you see or the image you see is a reflection of that light. This part over here, this you will see more so when you get into physics. We'll talk about an incident beam, what the normal is, and reflected beam, but for now you just need to know what the definition of reflection is. So, and again, a reflection is just when it bounces the surface and it can't go through it. So let's say you have a flashlight, you're reflecting that beam onto a mirror. What you see is a reflection of that light. So reflection is just a wave that can't pass through some kind of surface. Now a refraction, that is a bending of waves when passing from one medium to another. You've seen this when you put a straw into a glass of water. That straw kind of looks bent, right? Like it's been cut in half if you look at it from the side. That is an example of a refraction. You've seen it before, but might not have known what the term is for that. Now, this is just caused by a change in speed. Think about it. When you put a straw into a glass of water, if you look at it from the side, the straw was initially it's in a gas, it's in air. Then you put it through liquid. It is changing mediums. Therefore, you have a bending of those waves. So slower, more dense, light's going to bend towards, we call the normal. And then faster, less dense medium, your light's going to bend away from the normal. So an example of that would be, again, going from gas to liquid. The wave travels a bit faster in the liquid more so than it does the gas. This is just another example. So you can also think of a refraction as the bending of a wave as it enters a new medium at an angle. The refraction depends on the speed of light in the medium, and it also depends on the wavelength. And we tend to say that shorter wavelengths will bend more. And we'll get later, but blue has one of the shortest wavelengths. It travels faster. So here's another example. Let's say you're spearfishing. You may see the fish here, but because the reflection or the way the wave is traveling, the fish is actually a little bit away from that, because when a wave is refracted, the image will actually appear at an angle. So refraction, the wave as it moves around an obstacle or travels through a narrow opening. What this is right here, this would be like if you used a flashlight through a panel and there was a slit panel or a couple slits. You're going to see the light travel through those panels at different angles. We tend to say that the longer the wavelengths, we say red tends to have a long wavelength. It's going to be the opposite of a refraction. So diffraction is just a bend or kind of barrier. So interference, and again, depends on the kind of waves interacting. So interference is just normal waves that combine in a region of overlap. So we'll talk about the two types: constructive, where you end up getting a wave or destructive, where your wave gets smaller cancels out altogether. So in constructive bright light, again, two waves combine to form a wave with a larger amplitude. You're going to have a bright light. But deconstructive, you have a dimmer light because think deconstruction, taking something down, breaking it apart. The two waves end up canceling each other out, so you have a dimmer light. So both are caused by waves interacting, but again, constructive interference combines of two waves to a greater amplitude, whereas deconstructive reduces the energies of the two waves into a smaller amplitude. And sometimes, again, that can cause the waves to cancel each other out. One last thing, there's something called the Doppler effect, and you experience this on a day-to-day basis. So let's say you're walking down the street and you see a police car. You'll notice that the police car next to you hear pretty loudly. It has a high frequency, but as it travels away from you, that sound, the frequency seems to become smaller. So the Doppler effect is a change in frequency caused by sound. Listener